Hello. In this last module or submodule of the quality requirements lesson or module, I'll be talking about the relationships between quality attributes, or what comes next, and how these quality attributes are kind of processed into other, let's say, future project components or concepts. First of all, I would like to discuss about the relationships or interrelationships between quality attributes. I have already hinted to you when I was discussing about a certain quality attributes that I said, like, this quality attribute is closely related to the other one, and so on. And this is the this matrix shows in fact the entire picture. So they are rarely kind of independent of the other one. I mean, if you're talking about efficiency, it has a lot to do with performance. I mean, in this particular example, for instance, if you increase the efficiency, it's very likely that you will increase the performance, or portability or reliability is negatively kind of correlated with the efficiency. Okay, so I mean, this is not for you to kind of memorize or anything. It's just here to kind of for you to make sense out of these relationships. Please take a look at those two. That will give you a better idea of how or what that particular quality attribute means. Okay, fine. That's the first thing. The second thing that I'd like to talk about is as I have just mentioned, is how these quality attributes are translated into other project concepts or components. So some of the quality attributes are kind of translated into functional requirements, those things that the system are expected to do, okay, to provide as a functionality. For instance, security is a very good example. If you're talking about making your system secure, eventually it boils down to some sort of a function that the system should possess, should offer. I mean, if you're talking about like people have to enter using some username and password, then obviously the system should provide that functionality to users. Of course, it's not just the security, it has usability is one part, safety, what else, like installability and so on and so forth. But at the user level, I mean, it depends on where exactly you are or where you specify your quality requirement. At the user level, of course, you don't go, you just say that the system should have this kind of, should have this security, should have to handle the security. That's what the user is concerned about. But when it comes to the designer or programmer, security is fine, but they would like to see how they would like to, they have to implement that security into the system. Okay, so you transfer that thing and translate that requirement at the user level, that's something that's understandable by the user, into a function requirement that is understandable by the developer. Okay, the same goes for installability, integrity, reliability, and so on. Or sometimes they translate, like the statements about quality requirements or quality attributes are translated into system architecture. Availability, efficiency, modifiability are those examples, are very good examples that somehow relate later on to system architecture. Or interoperability, usability, or security requirements are very much relates to the design constraints. You say, I mean, use that kind of for instance, Mac OS feel interface. That is a design constraint. Or a design guideline, very similar, I would say, in this case. I mean, usability or scalability, reliability, or reusability are those kind of quality attributes or statements about quality attributes that can be translated into a design guideline or implementation constraint in the case of portability. If you say that this system should be easily portable into Android system, for instance, or an application that runs in Android should be easily transformed or kind of ported to an iOS device, you're talking about implementation constraints, because you're really very specific about the implementation, not necessarily design, but implementation, about like concrete implementation rules that you specify or you constrain the designer. Good. Last thing that I would like to discuss, and in this case I would like to keep it very short, is the phenomenon, or let's say is the fact that not all quality attributes are important for all types of software. Okay, so certain quality attributes are of particular importance for certain types of software or certain types of IT systems. For instance, if you're talking about corporate applications, ERP systems, CRM systems, production planning systems, and so on, we are talking about availability, or let's say those quality attributes will be very, very important. Which ones? Like availability, performance, scalability, security. Obviously, security is in fact important for almost all of them. Usability, oh, very, very important. Integrity, interoperability is yet another one that's extremely important. For instance, that might not be the case for embedded systems, interoperability, but for corporate applications, being able to, let's say, communicate with other type of systems, oh, extremely important. Desktop and mobile applications, usability, that is extremely important. Of course, usability is also important in other systems, but particularly mobile applications or internet web applications. I mean, desktop mobile applications and web internet applications are kind of, these days, that they come very much like, they're almost like united. But anyway, so reliability is another one, performance is obviously another one, security, as I just mentioned, availability, scalability, maintainability is very, very important when it comes to web, because that's very much like an ongoing process. The same goes for mobile applications these days. It's not the case that you just issue or release an application and then you just, like stop with it. You have to continue, and you have to improve it, and you release several new versions of your software, and reusability or maintainability becomes extremely important for you. Embedded systems, or sometimes also called real-time systems, like car system or washing machine system. These are, as you can imagine, they're a little bit different than the other type of applications, or corporate or mobile applications. In this case, performance becomes very important. Efficiency becomes very, very, very important. What else? Usability, yes, definitely. But reliability, robustness, safety becomes extremely important. Like safety, it's more or less irrelevant in many cases when it comes to mobile applications or corporate applications. But here for embedded systems, car, the brake system, hello. I mean, that is extremely important. Safety, reliability, robustness becomes extremely, extremely important for those type of systems. Fine. So that is it for quality attributes. I hope that you enjoyed it. That's extremely important. So perhaps a final word linking to the first example that I used to explain why quality attributes are important. I mean, the example of Windows Mobile and the iPhone and iOS. The extent of functionalities you offer is basically less important than how well you offer a certain or perhaps a limited number of functionalities. Okay, so quality attributes are as important and sometimes more important than the functionality.